Hi everyone, my name is Arun and I'm from Group 37 and today's presentation will be about the use cases of the project, potential upgrades and improvements, architecture diagram, workflow and a short demo of the project. The general use cases of the project are providing general health information and treatment procedures, giving users health tips for their well-being and suggest changes in lifestyle for a healthier environment. Checking for symptoms and providing accurate preliminary assessment is also one of the use cases. It can also provide basic first aid tips and suggestions for minor health issues. Since the project is a medical chatbot, the scope for improvement does not cease to exist. Some of the improvements that can be made are voice assistance for easier and faster assessment, the ability to process images like x-rays and prescriptions and images of injuries to assess and provide more accurate results. Since there are multiple ways of curing an ailment, the more data we have, the wider the scope for a better treatment procedure. Shifting the backend and LLM to a cloud server allows for access to the chatbot 24/7. Adding data in multiple languages and training the chatbot to answer in multiple languages can enhance user experience as they can choose the language that they are comfortable with. Coming to the architecture diagram, there are four main components, which are the web page, the embedding model, the RAG or the knowledge base, and the LLM model. Initially, the web page takes the user query and sends it to the vectorization model, which tokenizes the query and then sends it to the RAG. The RAG then uses similarity search algorithm, which is the FAISS model that we are using here, to retrieve the k most similar documents. The user query and the retrieved documents are then combined into a single document, which is then sent as a prompt to the LLM model. The LLM model then generates a response based on the given prompt and sends it back to the web interpage. The workflow diagram, as the name suggests, explains the flow of work during a query asked by the user. Even before the user uses the LLM, it has to be either trained on datasets or given a knowledge base, which here is a vector database. The database is first built by taking multiple large datasets and then tokenizing them using the All-Mini LM L6v2 encoder. And it is then stored in the vector database as a .pkl and .fass files. The user then gives a user query in the web page, which is then sent to the same encoder and tokenized. The tokenized user query is then used to find the most similar documents, which involves initially chunking the database into smaller parts and then taking the most relevant documents. The retrieved documents and the user query is then combined into a single query and is sent as a prompt to the LLM model. The LLM model then generates a response, which is then sent to the initial web page using API calls and HTTP requests. And I'm going to give you a small demo of the project. Start by logging in the credentials. There is a sign up page also. For the first question, what are rheumatoid arthritis symptoms? So it takes around 15 to 20 seconds to generate a response based on the length of the answer. And here we have the answer for the first question, which is on rheumatoid arthritis. Moving to the second question, what is autism and ADHD? ADHD. We've tried different models to try and reduce the time to generate the answer, but 15 to 20 seconds comes out to be the average of every generated answer. So we have the answer for the second one also. These are pretty concise. And going to the third question, what are the side effects of using aceclofenac for a long period of time? Uh, the greater the accuracy we have, the more time it takes to generate the answer because it is going through different documents to summarize and generate a response. There we have the answer for the third one. Mm, that concludes the demo. Going to log out. Thank you.